All right, guys. Let us do this. All right, so I sent some information to the group this morning. So essentially, what it is that, remember our aim was 24 mock exams, right? And the fact of the matter is that when I check the record, a number of persons are way behind that number of mock exams. With 3 weeks to go, we still can get to a good majority of those papers. They are all in the group. You just need to look at the list and see which ones you did not do and try and do them. The solutions are in the group, whether that be the video solution or the paper solution, everything is in the group. If you can't find it, let me know. We need to absolutely get those papers done. Now, can you imagine when exam come on May 9th? You see a question on the paper that is almost the same as one on one of the papers that you decided not to do. And they give you a problem. That's not going to be a nice experience. It don't make sense to get exposed to all this material and we don't maximize on them. We have to maximize on everything that is available. We are blessed, for example, to have all those paper ones, all those multiple choice papers. We know CSEC, they repeat a lot of the multiple choice. Where they don't repeat them exactly, they make changes to them. So at least you have a flavor, you have a feel, you kind of know the nature of the questions. And if they make the mistake and repeat any one, you should get it. To my mind, any question the CSEC ever set before, once you repeat it or repeat anything like it, you should be getting it correct in the exam. Why? Because you have the opportunity to access every single one of them before May 9th. And that's why I try to give you so much to do. I don't want to give you that advantage. You have to maximize on everything that is available. So you have to be honest to yourself and stop waste time. Right? Come on as the people watching videos and all them things. You could be working out a paper. Right? The videos and everything and the TikTok and everything, they're gonna all be available when the exam done. They're not going anywhere. But the exam over time when they go and come and done. So what you do, you commit yourself to getting yourself as prepared as possible for the exam, which is to maximize on everything that you have available. And one of the key things that is available is all these past papers that you can learn from. Do the questions, make a mistake, learn from a mistake, discover where your weaknesses are, work on those weaknesses, improve on them. You still have time. You still have time. Even 2 weeks, 2.5 weeks, 3 weeks to go. You still have time. You can mushroom. There's so much you can gain in a short time. Once you commit yourself to putting in that volume of work that is required. And you don't have to go searching for it anyway. It's all there in the group. It's all there on a list that I sent you. And if you can't find it, you just ask me directly. Sir, I don't have 2022 paper. I don't have 2020. Open the door. Let me see what it is. Nobody's there? Right? Any paper that you don't have, especially the most recent papers, January 2025, 2024 papers, the 2023 papers, the 2022 papers, the 2021, you're working your way down as far as you can go. You don't need to go back to past 2010. Right? The list that I sent you, work from that list of papers. You want to exhaust all of those. Now, even if you get to a stage where time is running out and you're not able to actually do the questions, at least read the questions and kind of work out in your mind, I can do this question. At least read the question and say, yes, can do this question. I don't have the time to do it, but I know I can do this question. Read another question. Yes, I can do this question. Read another question. I'm not so sure about this question. Let me try this one because I'm not so sure about it. Since we have limited time now, and you try to work it, and you check the solution, and you ask for the solution for it, right? And you know how you are with it. At least that. At least read all those questions on every one of those past papers. See the thing that they're asking. You will read and know that which ones you can do, which ones you understand, and you will know the ones that you're not so sure about. But at a minimum, that is what you have to do now between now and the exam. We can't go backwards. We can go forwards. So going forward from here, what it is, you cannot afford to miss anything when Mr. Shah gave for them. You can't afford to miss anything when I'm going for them. So all the papers that I have left to give you to do, you have to make sure that you do every single one of them. All the classes that are available, you have to ensure that you attend all of them. And if you notice, all these classes in this time, and I try to record all of them. Because I know persons have other obligations. For religious reasons, other reasons, they have other classes, they have other subjects doing this. I try to record every single one of them. So that you have those recordings in your own time, you can go and watch those recordings. Rather than watching TikTok. It don't make no sense. All right? Try not to miss anything. This is crunch time now. What irks me the most is when I know that I teach something and stress it and emphasize it and do a lot of examples of it because I already know the things that tend to give problems. And so I make a mountain out of a molehill with those things. I stress them, emphasize them, give examples in the notes, give our classwork with them. And then they come on a paper and somebody like them never see it before, like it's changed. Ridiculous. Them think they get me. I know I cover it. I know I emphasize it. I know I put a lot of time on it. And still some person like they're seeing it for the first time. You know why? Because students tend not to do what I ask them to do, which is to go home and repeat everything that we do in the class at a minimum. Go home and all the questions that we do in the class, all the examples that we do in the class, do them over. Especially if you do a question and get it wrong, you redo it. If you never know something and go through it, you go and work it over, do it over by yourself. Use the material, use either the video that I give you, or you use the documents, whatever. I provide you with everything you need. You have to know what you don't know. If you don't know what you don't know in problems, you have to know what you don't know. And the way how to know what you don't know is to expose yourself to the things that can come on an exam paper. They say, right, I don't know this. Let me go about getting the knowledge of this. You know where to come to for it. Come to sir. If you don't know where to go, come to me. Ask me. I'm going to tell you now. So you're not supposed to have no problem. If you have a problem, you know where the solution is. Just come to me and I'll explain how I'll go through it to the house. Send you the material that you need to get it or whatever it is. Because that's what we're here to do well in the exam. We're not here to go in the exam for grade 2s and grade 3s. We have to go in the exam for grade 1s with straight A's. That's what we're here for. Or to do the absolute best that you can do. Whatever your potential is, you need to maximize on that potential. You don't, in a sense, you have the ability to get a grade 1 and you end up with a grade 2. I don't, in a sense, you have the ability to get a grade 2 and you get a grade 3. You don't, in a sense, you have the ability to pass and end up with a grade 4. You know, in a sense. You have to at least attain your potential. And then with work, you can move that potential to another level, to a higher level, with work. So if your potential at one stage is a grade 2, you can work and move it to a grade 1. Come on, man. The next 2 weeks, I could push hard. I could go hard the next 2 weeks. Leave no stones unturned. I could be gung-ho about it. I'm not talking about maths alone. I always start like a maths alone. I'm not talking about maths alone. Whichever subject you're doing, you have to have a high level of intensity towards it. There's nothing sweeter than an exam result with successful grades on it. Nothing sweeter. When your exam result come out, and when you look upon it, you say all them bag of grade 1s, you straight A's, or you pass them, and you do well. If you know, say you're struggling at a subject or whatever, and you come out with a grade 2, you know yourself, you say, boy, you know, really work hard for that grade 2, yeah. I don't like them grades, I like so 1s, it's straight A's. But everybody now get 1 straight A's, so be realistic. But at least attain your full potential. Don't fall below your full potential. And to gain that, you have to put in work. There's only 2 weeks left. If you're going through the whole exam process, the whole exam period, you look like, what, 2 months, May and June. Man, must have made a sacrifice of that dedication there for 2 months. Try to get the best grade possible out of your exams. Not just maths alone. Dedicate yourself, man, and just put in the work. I tell the students yesterday, there's a direct relationship between the volume of work that you do and the exam result that you get. The more work you put in, always equate out to the better your grades. That's just how it is, regardless of who you are. The more work you put in is the better the grades gonna be. Right? So if that's how it is, then put in as much work as possible because you want the best grades possible. You get me? You want to feel proud on when exam done, when exam results come, not just for maths alone, everything. All the subjects then. You want to see the exam results and feel, say, yes, I know this student come to class and look on the results and feel good, feel proud, a motivation to come and teach again another year. You get me? I want to do well, man. I want you all to do well in every subject, especially maths, my subject. Especially maths. But I know what it takes. And some of you are not showing it now, but you still have time. Not giving up on anything. 3 weeks to go, you still have time. Maximize on the effort. Put in as much work as you can. Right? Don't waste time, man. You don't know the things that waste time. You have to have strong will and strong mind to put away the things that waste your time and go after the work. So everything I'm going to do, you know, on the exam, I have to do it. And I sent something for you to do yesterday. I sent 2 papers in the group. January and June 2022 papers. Send them in the group. I wanted to complete those 2 papers before Wednesday. Complete those 2 papers before Wednesday. June and January 2022, I sent those papers in the group. Very, very important that you complete those 2 papers before class on Wednesday. I am contemplating having a whole day class Wednesday and a whole day class Thursday since it's holiday. Who can come, who can come, is all right. The class would have been in the evening. I know some of you still have classes in a school or wherever. But I'm going to find out and see if we can just come here and just provide environment for you to practice and work until class at 5 o'clock. We do what we're doing at 5 o'clock. The class is at 5 o'clock. The class on Wednesday is at 5 o'clock. Wednesday and Thursday this week, 5 o'clock in the evening. Yeah, because I work day for me. But I'm thinking of taking vacation those 2 days and just come here from the morning. I'll just work through the day. But I will confirm it. Maybe by tomorrow I'll confirm it. On Wednesday, since everybody's on holiday. But one of the reasons I need to find out, I need to ensure that the room is available during the day. You understand? That is what the issue is. I need to find out that the room, especially the rooms, available during the week on Wednesday and Thursday. I'm going to find that out tomorrow, and then I will let you know. All right? So that is the plan, guys. Make go hard over the next couple of weeks. All right? Go hard over the next couple of weeks. All right. This paper now. You know, this paper gave a lot of problem when it was set this year. 2019, a lot of teachers complained about this paper, especially the pattern question. There was a lot of uproar about this paper. But I personally never really seen the problem with it, to be honest. All right? But people tend to focus on what gives them problem in the exam, rather than the whole paper. So if one question on the paper and give people problem, them start at the paper, then hard and all of that, with just one question alone. But a lot of people didn't like this paper. So if you felt comfortable on this paper, good. That's nice. This one, yes, 2019. This is the June one. No, that's the one we worked out yesterday. This is the other one. This is the other one. This is the other one. The June one is the one that gave people problems. So that one you're talking about worked out yesterday. So if you don't see it yet, I send that video solution in the group. All right, let's go. First question, use a calculator or otherwise to work this out. So use a calculator, I'm going to put everything in the calculator as you can. So that's a mixed number, 2 1/4 minus another mixed number, 1 3/5, 1 3/5, and over 3. 0.2166 is repeated. As a fraction, you're gonna be 13/60. That's it. Just make sure that what you have is the same thing that is there. 2 1/4 minus 1 3. All right, good. That is it. Next question. Clearly, let's calculate this. Work this out. Give the answer to 2 decimal places. Again, clear the calculator and put that in. 2.14 times the sine of 75 degrees. And you look up here, make sure that you have DEG on the top up there for degrees. Make sure your calculator is in degrees. That's 2.067081. And I want it to add 2 decimal places, so I'm going to correct it to 2 decimal places. These are the 2 decimal places. Using this 7 to correct that 0.06, it turns it into 0.07, sorry. So it becomes 2.07 to 2 decimal places. 2 decimal places. That is it. 2.07. Nice and easy. Let's continue. This question now. It says Herman's take-home pay is $4,320 per fortnight. A fortnight is 2 weeks. Each fortnight, Herman's pay is allocated according to the table below. All right. So remember, the total is this, and that's how she allocates her pay, right? So she put this amount on rent, X, you don't know X. She put this amount on food, other living expenses is 2 times X, and then she saves this amount. It says, what is Irma's annual take-home pay? And here I have to assume that there are 52 weeks in a year. Now, if there are 52 weeks in a year, and there are 2 weeks in a fortnight, it means that she's working 26 fortnights, half of 52, right? That's 52 weeks divided by 2. That's the number of fortnights, right? So it's 26 fortnights. I divide this by 2 to say the number of 2 weeks that is in it. 26 fortnights. What is Irma's take-home pay annually? So it's basically 26 times this. That's the annual amount, right? So this annual amount is equal to 26 times 4320, which looks like a 26. So it's 26 times 4320. That is 112,320 per year. That's the annual amount. But good? Nice and easy. Next part says, determine the amount of money that Irma allocates to for rent each month. All right, so here's the problem with this now. You're going to have to assume what amount is. Because the question only spoke about fortnight, right? So we're going to have to assume that amount. No, we don't have to do that, you know. We can work out the annual amount based on the 26 and then divide it by 12 to get the per month. But understand that? Since they give us information in fortnight and they tell us they tell us how much weeks in a year, what we can do is work out the amount that she pays annually and divide that by 12 to get the monthly. You get me? We can't assume that it's a straight 4 weeks make a month for this question based on the information that they gave us. All right, so we need to work out how much you paid for rent in a year. All right. So the first thing we need to do is work out what the rent amount is, what X is for each fortnight. Multiply that by 26 to get the annual figure, and then divide that by 12 to get the monthly figure. Understand that? We need to work out what the rent is per month. We can work it out right here. So basically, everything here must add up to that 433. Let me see if we work it out in a space down here. What space we have? All right, let me work it out up here. I'm going to work it out right here beside it. The total must be this. So you know that x plus 2x is 3x. Plus this. That all must be equal to 4320 again. Let me make this smaller. And therefore, this 3x is going to be equal to this amount minus these two. So 3x is going to be equal to this amount minus the. I'm just going to subtract them one time, right? Subtract them. So I'm going to do 4320 minus 629 and also minus 1750. That's 1941. That's what 3x is equal to. And therefore, x is equal to this divided by 3. I'm going to divide this now by 3. 1941 divided by 3. And I'm getting x is $647. Well, it's x because the dollar is an x already. So x is 647. So the rent is 647 per fortnight, right? But I can say that? Good. So we'll go down here now and work out the rent per month. So the rent X is 647 per fortnight. And there are 26 fortnights in a year. So that's 647 times 26 per year. Agreed? Agreed? And then to get per month, we divide this now by 12. Because we know say 12 months make a year. So this therefore equals 647 times 26 divided by 12 per month. But understand the calculation? First thing we have to work out what was the rent per fortnight based on the table. So what we use is that the sum of all of this is that. And from that now we can work out the x by subtracting, right? So the x come out to be this. That's per fortnight. They wanted our rent per month. And then they give us any information about month. But what we know for sure is that a year has 12 months. So the approach then is to work out how much is our rent per year. I would know the rent per fortnight, you know, is 647. Multiply that by 26, because there are 26 fortnights in a year. Multiply that by 26. So this is the yearly figure. I don't have to actually work out the figure for rent. And then once I have the yearly figure now, I divide the yearly figure by 12. That is the per month figure for rent. But understand that? Good. So I'm going to do it that way. So we're doing this calculation. So it's 647 times 26, that's the annual figure, divided by 12, that's a monthly figure. So I'm getting 1401.83. That's the amount per month. Rent per month. That's my calculation. I'm sticking to it. I think some persons might say, okay, 4 weeks in a month and do 2 fortnights. But yeah, I don't like it because they did not define what a month is. They only define a year in terms of fortnight. Huh? No, I don't think I give it the same thing. Because we all know that you don't have the exact 48 weeks in a year. They're not going to get the same thing. All right. Anyway, let's go. Next question says, all of Irma's savings is used to pay her son's university tuition, which is $150,000. All right. It says if Irma's pay remain the same and she saves the same amount each month, see them come back to month again, and she saves the same amount each month, the minimum number of years that she must work in order to save enough to cover her son's tuition is what? What is the amount how much time she have to work? So we're gonna have to work out how much she saves per year. So the amount that she saves per year, they want it in a year now. They want it in a year. Huh? How many years? So the amount she saves per year is this. This is our savings for a fortnight. We'll multiply that by 26 to get the savings per year. Then now you know the amount that she's putting those savings towards, which is 150,000. She's going to divide the 150,000 by the savings to see how many years she's going to be paying for. But understand that? Good. So the savings per year is going to be the fortnightly saving. What is it again? Fortnightly saving is 1750. 1750 times 26 fortnights in a year. Let's just see what it is. I don't have to, but let's see what it is. Times 26. Sure. So that is 45,500 per year. I should put all of this towards the tuition. And the total tuition is 150,000. So to know how many years you have to work, how many times you have to save this to make that amount, that's how we divide. So number of years savings to make this tuition. Number of years. Number of years that you have to save. Or that you have to work. It's going to be equal to 150,000 divided by the amount that she saves per year, which is 45,500. And this works out to be 150,000 divided by 45,500. That's 3.3. So this is 3.3 years. So she'll have to work past 3 years. So she'll work 4 years. So she'll have to work 4 years to make it. Understand that? She have to work past 3 years. She have to work past 3 years. But this is saying 3.3 years. Oh, you don't have to give a whole number answer. But once a question asks for this, the number of something, they're looking for a whole number. When you do that, generally speaking, if you do a question and ask for the number of something is a counting number. They're not going to put 3.3 years. She has to work 4 years. The number of years she has to work for is 4 years. Because she has to work past 3 years in order to accumulate the savings. So she has to work for 4 years. Don't put 3.3. All right? Once the question asks for the number of something, you tend to put a natural number, a counting number. So she's going to have to work for 4 years. All right? That is the question 1. That's what a nice question. I like it a lot. Next question. Simplify this as a multiplication. This is equal to. You multiply these two numbers to get 12. When you multiply these two indices, you add the power. When you multiply indices, you add the power. So you get p to the 2 plus 5, which is p to the 7. So you get 12 times p to the 7th power. That is it. When you multiply indices, you multiply this time this, you add the powers. Next question. Simplify this. When you divide a fraction, you invert and multiply. So this basically becomes 3x over 4y cubed times, you flip this. Reciprocal of that is 20y squared over 21x squared. And then start to cancel down common factors now. So you can get a y squared out of this and a y squared out of this. This cube will leave it y to the 1 power, like you subtract them. Then an x out of this, cancel x out of this one, leave it with an x to the 1 power. The numbers now. You can get 4 out of this, give you 1 times, 4 out of this, give you 5. Then 3 out of this is 1, and 3 out of this is 7. What are the numbers we have left? We have 1y and 7x. 1y times 7x. Under here is 7xy. Then up here we have 1 times that 5. That's 5. That is it. But I go to that, cancel down the like terms. Simple as that. Take your time and cancel them down. All right, that is it. Next one. This one says we have to solve this. Solve this. Solve means to make extra subject. This can be done multiple ways. I can make this into one fraction first. And if you have a fraction equals 0, only the numerator equals 0. It's one way. Or I can transpose this over here and then cross multiply and put it as 3 over 7x minus 1 equal minus 1 over x. And then cross multiply. Multiply this up here and multiply this up there. That's another way you could do it. And expand out and group x terms on one side. That's another way you could do it. So you have to decide which way you prefer. All right? I'm going to use that way. I transpose this over here and cross multiply. Look like it's the easier way that to me. Or you could, I know, let me do it the both ways. Let me do it the 2 ways. More maths equals better maths. Let's do it both ways. I don't need a calculator now. Let's do it both ways. Let me divide the screen and do it 2 ways. I'm going to do it where I turn this into one fraction first. So to turn this into one fraction, I'm going to multiply this fraction by this new denominator. So multiply this denominator up here and here because you want the 2 denominators to become the same. You want these 2 denominators to become the same. So it's 3 over 7x minus 1. I'm going to multiply that fraction by x over x plus the 1 over x, multiply that one with this denominator. 7x minus 1 over 7x minus 1. And that's all equal to 0. So this fraction I'm multiplying it by x over x. This fraction I'm multiplying it by that other denominator. So now what's going to happen is that they're going to have a same denominator, which is x times 7x minus 1. Then now this numerator becomes 3x. And this numerator becomes 7x minus 1. That's all equal to 0. If a fraction equals 0, then the numerator must be equal to the 0. Because like you take this denominator and multiply it over here, so by the 0, it's going to become 0 anyway. So the numerator equals 0. So this numerator is equal to 0. So this 3x plus 7x is 10x minus 1 is equal to 0. And so based on this, the x equals 1 over 10. Q over the 1 become positive 1 and then divide under the 10. That's one way. Let's do it another way over here. Other way that I showed there. Without forming the single fraction. Let's do it another way. More maths equals better maths. Let's do it another way. So the other way, I'm going to take this and transpose it over here first. And it's going to become 3 over 7x minus 1 equal minus 1 over x. When I take this and bring it over here, it become minus. Then now I'm going to take this denominator and multiply it up here. And take this denominator and multiply it up here. So I'm going to get 3x equal minus 7x minus 1. Because I'm taking this and multiply by the minus 1. So it becomes this, minus 1 times that. Expand this now. I could have expanded it right away. It's 3x equal minus 7x plus 1. This minus give me a plus 1. So bring this over here so you get 10x again. Equals 1. Same way. So again, x equals 1 over 10. So whichever way you prefer, that is it. All right? Whichever way you prefer. The answer is 1 over 10. Next question. Question says, when a number x is multiplied by 2, the result is squared to give a new number y. Express y in terms of x. Let's write out what I said. When a number x is multiplied by 2, that's 2x. The result is squared. Square that. To give a new number y, that is equal to y. What is that? That's what I basically said. The number x is multiplied by 2. The whole result is squared to give mean equal a new number y. It means that we can say i.e. y as a subject, I'm saying express y in terms of x, meaning make y the subject. The y is equal to, this really becomes 4x squared. Okay, square the 2, you get 4. Square the x, you get x squared. So it becomes 4x squared. But I got that? Simple. Next part says, determine two values of x that satisfy the equation y equal x and the equation derived above. So in other words, we're solving simultaneously y equals x and y equals 4x squared. This is the equation from above. We're solving them simultaneously. There are the two values of x that satisfy those two equations. You have to solve them simultaneously. And I only want the values of x. So get the value of x. If y equals x and y also equals this, it means that this thing equals that thing. Because the two of them equal y. Right? So we can say that implies that 4x squared is equal to x. I was solving this on an equation now. Now what you do? Let's go now. Do not divide by the x. You must never cancel out an unknown that you're trying to work out, you're trying to find. You must never cancel out an unknown that you're trying to find. You factorize it out. The reason why you can't divide out an unknown as well is because the unknown might be 0. You can't divide by 0. You get me? So you don't go dividing both sides by x here, so. Nope. Because it's an unknown quantity. If you know what it was, I know that it is not 0, then you could divide by it. But because it has the possibility of being 0, you cannot divide by it. So do not go and divide out x here, so, and cancel it out. You're going to lose a result. You'll be eliminating a result. You factorize what you're trying to find. Factorize it out. So bring the x over here, so, and write it as 4x squared minus x equals 0. There's a quadratic. Factorize out the x. Out of this, you have 4x. Out of this, you have minus 1 equals 0. Then it's either the x equals 0 or the bracketed term equals 0. When you have a product of two things, this times this equals 0. Either the first thing equals 0 or the second thing equals 0. So it's either the x equals 0. That's one answer. Or if you put this equals 0, what would you do to find the x? Show the one first, make it positive, and then divide under the 4. So the x would be positive 1 over 4. So those are the two values of x, 0 and 1 over 4. If you divide out the x, you would not have this as an answer, the 0. You don't only have this one. You would have thrown away a result. You get me? That is it. But good? But okay? Pass mark is 65% now. 65. 65%. Next question. Construction. Use a ruler, pencil, a pair of compasses to construct triangle LNLM. Let's sketch it out. Sketch it and then you construct it. Sketch what they say and you construct what they say. So LM is 12. So we're going to draw LM like this. 12. Put L here so, M here so. And then the angle at L is 30 degrees. So right here says 30 degrees. And the angle at M, see there, angle at the middle is 90 degrees. So right here says 90 degrees. 90 degrees. So that's what you're constructing, guys. You're constructing a 30 and a 90 on either end of a line that is 12 centimeters long. That's what we're constructing. Let's construct it. Let's construct it over here. Where are you? Construction, right here. Let's construct it. So remember, to construct the 30, you bisect 60, right? So all you have to do to get the 30, you bisect the 60. Ready now? So the first thing we need is our 12 centimeters line. What a long thing. I don't have this way whole. Let's put it down here. So 12 centimeters with a ruler. Question say you can use a ruler. That's my 12 centimeters. From one end, I'm going to construct the 30 degrees. Let's construct it in red. So remember now, when you open the compass, you lock it. I'm not going to change it again. So you set it, I'm not going to change it again. You're not going to change the angle of the compass once you start the construction, right? So to construct the 30 degrees that I'm going to construct a 60 and then bisect the 60. And I don't need to construct the 60-degree angle. I only need to construct the 60-degree arc and bisect the 60-degree arc. So here now, only the two arcs you need to form a 60-degree arc. That's one. Don't change the angle of the compass. Don't adjust it at all. Move the point to here. Rotate it over to cross this one. Cross that one. What you have there is a 60-degree arc. I don't need to draw the angle. I just need to bisect this arc right here that you're seeing on the screen now. This arc right here, a 60-degree arc, I just need to bisect it. You bisect it in a different color. So to bisect it, you come on either end of the arc. One end of it there, rotate it over, and make an arc around halfway. Come up to the other end of the arc. Rotate over, cross that one. The straight line through there, so now it's going to be 30 degrees. Because I bisected that red 60-degree arc. I need to construct a 90 at the other end. Construct a 90, the method we use in this class is to construct a 120, divide 60 and 60, and then bisect the second 60. So the 60 plus the 30 make the 90. That's the method we use in this class. There are multiple other ways to do it. All right? So let's go back for the red again. So come back over this end now. I'm going to construct from this end 90 degrees. So you want to make a long arc. I want a full 120-degree arc all the way over there. Long arc. Come to this end, that intersection, cross that one. That's the first 60 degree. Come up at this intersection here. Rotate over. And then cross that one again. That's 60 and 60 right now. I need to bisect the second 60 to get the 30. Let's change the color again for the second bisection. Let's put it in green. So I'm going to bisect this top 60 up here now. This top 60 up here, I'm going to bisect it. So I come to one end of the 60, position it around where the 30 will be halfway there. Somewhere in there, the 30 is going to be. It's going to bisect it. Come over to the next end of the 60. Rotate. And make that arc. And basically, that is it. So all I need to do now is draw my lines. Go back for the block. So over this end, I'm going to draw my 90 of here through the intersection. That's 90. And from this end, I'm going to draw my 30 through the green intersection again. Make sure I pass through here. That's 30. Then I can label up now. Down here is L. Down here is M. Up at this intersection is N. Right up here is N. This angle down here is 30 degrees. This angle here is 90 degrees. That is my construction. Down here is 12 centimeters. You have to practice it. You don't know what's coming on the exam. I noticed in recent times, they're not really giving full construction like this anymore. They kind of give you some question where you have to bisect two angles and bisect a line and stuff like that. They're trying to show in some of the questions now how the construction can be used in real life situation. I think the last question in this year, January, there's a question about them wanting to place a light pole on a football field. And they said the light pole must be positioned so that it is on the perpendicular bisector of one line, and it must be at 30 degrees from one next line. And you have to construct the final position of the light pole, something like that. I said another question one time, they said they want to put a fence on a field, and the fence must be equidistant from two lines. They know say you bisect the angle between those two lines, basically. You bisect the angle between those two, something like that. So that's what they're trying to do in recent times, rather than construct triangles and stuff. But you still have to learn how to do this just in case. All right, that finishes that question. I see you have to show all those construction lines in red and green. You have to show those lines in red and green. You draw them in pencil. All right, that finishes that question. Part B, transformation. Mute the mic, please. Points A, B, and C are shown in the diagram below. You can see them right here and give the coordinates. All right. It says ABC is mapped to LMN by a reflection in the x-axis, followed by a reflection in the y-axis. It says on the diagram, draw the and label LMN. This is the image. So let's make a note. The A going to L, right? A going to L. The B going to M. B going to M, because the letter is different, you have to make sure. C going to N. C going to N. Just want to make sure. And we're doing two successive reflections on each point. We can just complete it. Reflecting over the x-axis and then reflecting over the y-axis, which you should know is equivalent to a 180-degree rotation about the origin. You should know that. Reflect over the x-axis and reflect over the y-axis is equivalent to a 180-degree rotation about the origin. Why? But the angle between the x-axis and the y-axis is 90 degrees, and they intersect at the origin. And so those two reflections are equivalent to one rotation, twice the angle between the two lines. 2 times 90 is 180. And the point of intersection of the x-axis and y-axis is the origin. You should know that two reflections over intersecting lines is equivalent to a rotation. Twice the angle between the lines, and the center of the rotation is at the point of intersection of the two lines. The more things you know, the better. Those things are on the must-know sheet that I gave you. All right. So they want us to construct the triangle. So we're just going to do the full reflection. X-axis and then y-axis. 1 point at a time. Let's do A first. So A is the x-axis and then the y-axis. Two reflections, right? So A reflecting to here first. 1 unit to here, 1 unit to 1, coming to here first. And then reflecting to here, 1 unit over here to here, so too. So A coming there, so don't it? So A coming right here, so. And A went to L, right? So right here is L. Come on, come on. That's the first part. Then B. B is reflect over the x-axis first. It is 4. So you're going to go 4 on the other side to down here. And then 1 across the y-axis. That's 1 from the y-axis. So it's going to go 1 across the y-axis to here. So B coming to right here. Same as reflecting through the origin. A 180-degree rotation about the origin. Same as reflecting through the origin. So B went to LMN, went to M right here. M. And then the last one, reflect over the x-axis, the C, reflect over the x-axis to here first, then reflect over the y-axis. So it's 3 units to the y-axis to here, 3 units on the other side to here, to there. So that is where that point is coming. Reflect through the origin to there. That is it. Those are the 3 points, L, M, N. So see it here, this is a triangle. Same as a 180-degree rotation about the origin. There are straight line between those 2 points. But I go to that. That is the image. Reflect over the x-axis and then reflect over the y-axis. That's what we get. All right. On the diagram, draw and label the triangle. Bam, that is it. Done. Next part says, describe fully the transformation which maps this to this. You must know the 180-degree rotation about the origin. Because as I tell you, 2 reflection over intersecting lines equivalent to 1 rotation. Twice angle between the lines, and the center rotation is the point of intersection of the 2 lines. So this to this is a 180-degree rotation about the origin. I'm going to say clockwise. Why? Because the reflection was this way and then that way. That's why I'm going to say clockwise. Because the 180 degrees rotation is the same whether they go clockwise or anti-clockwise. So 180-degree rotation about the origin. That's what it is. 180 degrees clockwise rotation. About the origin. So make sure you cover the description. For rotation, I get the name and 3 components: angle, direction, and the center for rotation. Angle, direction, and center. All right, that is it. All right, next question. Here says, state the 2x2 matrix for the transformation. See, you have to know it. There's 2 of them in 1. -1, 0, 0, -1. Get your 1 mark easy. You don't need to figure it out when you know it. So you can set up where you have to know the matrices. That represents the y-axis part of the reflection. That's the x-axis part of the reflection. That's the matrix for 180-degree rotation about the origin. Same as a reflection through the origin. So here we could have said a reflection through the origin. But that's not really one of the standard reflections. I tend to give reflection over lines. But that's the same as us reflecting through the origin. See here? At this point, and we could have reflected through the origin straight to here. So see there? Treat the origin like a mirror. See, they reflect this one through the origin. Take this one and reflect it through the origin just the same. Same as reflecting through the origin. But I'm working with 180-degree rotation about the origin. That's it. That's the matrix for it. Done. Get your marks quick and go about your business. More things you know, the better. That's the matrix. Next part. It says, quantity P varies inversely as the square of V. Note this. It's not just V, you know, this is the square of V. Square of V is V squared. So this first variable is inversely proportional as the square of V. So it means that the first variable is equal to 1 over, no, not 1, k over the second variable. That's the relationship. And it's inversely. If it was direct, it would be P equal K times V squared. If this would have been direct, that's a directly proportional. It's just a direct variation. But this one is inversely. Inverse is K over. First thing is K over the second thing when it's inversely. Directly is K times the second thing. Come on, I forget them things now. And what I like to do this question is make K the subject. When the inverse variation, I like to make K the subject. That's kind of easy. Take the V squared and multiply it up here. So you see that P times V squared is always a constant. So the product of P and V squared is a constant value. So the P times V squared to all the pairs are the same. So sometimes I don't need to work out the K. But let's see if this one wants a K. It says, given that V equals 3 when P equals 4, determine the value of V when P equals 1. It's not this easy, you know. P times V squared is a constant at all times. So the P times V squared from the pair there equal to P times V squared from the pair there, because they equal a constant. See it here? P times V squared for this equal P times V squared for that, because it's a constant at all times. P times V squared for this pair of value is equal to P times V squared for this pair of value. Because the P times V squared is the same value all the time. It's constant. You don't need to work out the constant. So the P times V squared right here says what? Is 4 times 3 squared for that pair here. Equal to P times V squared for this one. The P is 1. That is 1 times V squared. The V you're trying to find. I'm trying to find the V from this. But I said that. Good? And so now the V becomes the square root of this. What does it work out to? That work out to 36 now. Or if you square root this part becomes 2 and this part becomes 3. So the answer is 6. 2 times 3 is 6. If you square root this, see? So the V over here so becomes the square root of 4 times 3 squared. Square root of the 4 is 2. Square root of 3 squared, which is 9, is 3. So this becomes just 2 times 3 is 6. Or you can say this is 36. Square root of 36 is 6. So therefore, the V is equal to 6. This works out to be 6. This is the answer. The V equals 6. That's the answer. But understand that. But good. If you want to do it one way where you work out the K first, no problem. We have to learn how to do the maths efficient. Finding the K in a question like this is a waste of time. You don't need to work it out. You don't need it. You find the K, then write by the formula, and then after you write by the formula, you plug in the 1. Waste of time. You don't need it. All right? P times V squared for this pair will be P times V squared for this square, because that's what happened here. P times V squared is a constant for any pair of P and V. That's it. All right, let's continue. 2 times 3 is 6. All right, that's done. Next part says, given that x is a real number, solve this inequality. So to solve this inequality, you want to leave x alone in the middle. You want to transpose everything away from the x that is in the middle and leave x alone in the middle. That's why you solve that inequality like that. Some people divide it into this half, or that side, the left side, and the right side. But you have to do that. Only way you have to do that is if you had some x on these expressions as well. But those are numbers. The only x term in there is this one. So it means that you can transpose all the numbers away from that x. Remember, it's still an inequality. And if you have to multiply or divide anytime with a negative number, you have to reverse the inequality signs. I'm going to move everything away from this x and leave it in the middle. First I'm going to move is a 5. So I'm going to subtract 5 from the 3 sides. This expression has 3 sides. So subtract 5 first. When you subtract 5 from this side, it becomes negative 12. Less than. This is the less than. Inside it just become 3x. Less than or equal to subtract 5 from this, I get 2. But I said that subtract 5 from all the sides. Then to get up this 3, I need to divide all sides by 3. Divide all sides by 3. So I will divide now by 3. And I'm dividing with a positive number, so there's no need to reverse the sign. Sorry. Divide this by 3, become -4. Less than, this becomes an x. Less than or equal to divide this by 3, I get 2/3. That's my solution. This my answer. X alone left in the middle. So subtract 5 from all sides first. Then divide by 3. That's it. Anybody got that when they did it? All right. Next part says, represent this on a number line and I put in a 0 for you. All right. So this one don't quite reach 1, you know, that's 2/3. That don't reach 1. That's 2/3. And this is -4. And you have 0 here, right? So let's put in a number line starting from 0. So I'm going to put 1 over here. 1. Then -1, -2, -3. Let's put -4 down here. So it's not to scale. -4. All right. Let's draw it now. So the critical value on the right side is 2/3. So I can take this one section and divide into 3 equal parts. So right here, so it'll be 2/3. 2 out of 3 part, that 2/3. Right here is 2/3. And then you have the next value is -4. Right down it says -4, right here. So the circle on the -4 is unshaded because there's no equal on that part of the inequality. It's an open end, so it's unshaded. So put a circle on the 4, but unshaded. The circle on the 2 though, and the 2/3 is going to be shaded because the equal is a part of that inequality. So you put a circle on the 2/3, and you shade it because of the equal. And then this x now, you just want to reach in between them. So you just join these now. So this way. That's the number line for this. You're between these two values. So the x is less than or equal to the 2/3. That's on this side. And the x in the middle is greater than the -4. That's the number line for that one. But I go to that. If you never get it, you're going to do it now. Anybody have any question on this? Everybody okay? All right. But understand why I'm leave this one unshaded? Because there's no equal on this end of the inequality on that value. So it means that -4 is not a valid value. Can't include the -4. To show that you don't include the -4, you leave it unshaded. And on this end, the 2/3 is included. To show that the 2/3 is included, you put the bubble on the 2/3 shaded. Or the circle on the 2/3 shaded. All right, and then this now the x is between them. So that's why I mark the region between them. That is it. Next part says, they give us that equation of a straight line. It's another question the teacher complain about. So by the numbers, set it out more simple than this, but it doesn't matter. That's what it is. It's a line crosses the x-axis at Q. You know that on the x-axis, on the y-axis, sorry, x equals 0, right? And I want to take the coordinates of Q. So you're going to put 0 inside here, so. So you put 0 there, you're going to get 0 over 3 plus y over 7 equals 1. So this is 0. So y over 7 equals 1. Multiply this, the 7, you get y equals 7. So Q is a point where x equals 0 and y equals 7. So that point is 0, 7. That's the point Q. Question asks for the coordinates of Q. You cannot just put y alone. You have to put both of them. Once the question asks for coordinates, that's why you write coordinates in the bracket, the x value and the y value, even if one of them is 0. So this is the answer right here. That is the answer. And put a Q on it in front to show me the Q we're talking about. They say, what is the grade of a line? To get the grade of a line, we need to make y the subject. Take the equation and rearrange it, make y alone the subject. All right, let's do it right here. Let's do it right here. So we can write the equation. So first thing I'm going to do is transpose this x over 3. All right, so I'm going to get y over 7 equals minus x over 3 plus 1. Then to get rid of this 7, remember I want y alone now, I need to multiply all the values now by 7. So the y alone is going to be negative 7 over 3 times x. Multiply the 7 by this, I get that up. Why am I writing like that? Because I want to see what the m is times the x. That's why I'm writing like that. Right? If I multiply this by 7, it will become negative 7x over 3. Break off this x off it and put a minus 7 over 3x. So I can see the m. That's why I write it like that. Because I want to see the m. So right now the m is negative 7 over 3. You know? And then this now also becomes a plus 7. That's why this was the y-axis intercept here. See it? The 0, 7. So the gradient now is this. So I can write it down. The gradient of the line is minus 7 over 3. But this is the m. But I go to that. This is y equals mx plus c. That's what that is. So the m is negative 7 over 3. Next part. Oh, done. Easy. But all right. That is it. Next question. So you see, if you had originally taken this equation and write it like this at the beginning, you could know that this is the y-axis intercept and this is the gradient straight. So you see it by writing it in the standard form right here. You can see it. All right, that is, let me shift this over. All right, that done. Number 5. Remember this question as I see it. I'm going to point it out here right away. You have to have sharp eyes. We are used to them giving us frequency distribution tables with frequency. This is the cumulative to the frequency. And that's what got a lot of students in this question. That's another one of the reasons why they never like this paper. Because normally they only just give you a frequency. But they can give you a cumulative frequency. And what you have to do is work out what the frequency values are by just subtracting the cumulative frequency values to see what the frequency values are. Get me? So I get a table like that. I want to work out the frequency values right away. I'm not going to wait. So you know what the frequency of each line is by subtracting the cumulative frequency values. So I'm going to put in the frequency values where it is normally. It is normally in front of the cumulative frequency. I'm going to put it right here. Frequency. I want it to look how it normally is. Frequency normally comes before the cumulative frequency. I'm going to put it where it normally is. So before we start the question, once we see that that's what they give me, I'm going to work out my frequency values then. Question is going to set to test the knowledge of that for sure. So the first value is always the cumulative frequency value, which is 24. Good? Remember, it is 24 you add to a value here to get this, don't it? So to get the value, you just need to subtract 59 minus 24 now, don't it? This minus that, which is what? 59 minus 24 is how much? 35. So this is 35. But I go to that. Remember, write the calculation in here. 59 minus 24 equals 35. Then here now, this you add to this to get this one, don't it? So again, I'm going to subtract 101 minus 59. 101 minus 59. How much is that? How much? 42. Then is this you subtract from that again to get this one because you add this to this to get that. So again, it's 129 minus 101. How much is that? 28. So this is 28. And then you add this to this to get that. So you're going to subtract them now. You're going to do 150 minus the 129. How much is that? 21. 21. And then to make sure you add up these and it must come to 150, don't it? That's all? Just to make sure you can add up all of these and it must come to the total frequency just to see. Because this represents the total frequency. Make sure. Ready to answer questions now? For the different frequency, I know I need the frequency. Question says, so it's a distribution for the volume of petrol needed to fill a tank of 150 different vehicles as shown in the table below. It says for the class interval 21 to 30, that's this one right here. What is the lower boundary? The lower boundary is 0.5 less than that, don't it? Or the halfway mark between this and this. That's 20.5 liters. Put on the units. 20.5 liters. Don't just put 20.5, put 20.5 liters. Put the unit there as well. That's a lower boundary for that class. Put the liters. Next one, the class width. Class width, remember, is not the upper limit minus the lower limit. It is the upper boundary minus the lower boundary, and you can know by looking at all these values going up. They're going up by 10. So the class width right now is 10, you know, because these jumping up by 10, and these jumping up by 10. So the class width is 10. But proper calculation is the upper boundary minus the lower boundary, not limits. So it will be 30.5, the upper boundary, minus the lower boundary of 20.5. That's the class width. Upper boundary minus lower boundary, that works out to the 10 liters. Don't give it away, 10 liters. Don't do 30 minus 21, please. Don't do 30 minus 21. Remember now, values in this group can start from 20.5 up to 30.5, up to less than 30.5. That's what the class with. From 20.5 up to 30.5. That's why that is a class with. The class with like the range of values that can fit in that interval. That you put in that interval. Next part says, how many vehicles were recorded in the class 31 to 40? 31 to 40. See it here, 42. But I say that, that's how we did the frequency there. See it? 31 to 40 or 42 vehicles. That's it, the frequency value. In that interval, 42. 42 vehicles. 42. Vehicles. It says a vehicle is chosen at random from the 150. What is the probability that the volume of petrol needed to fill a tank is more than 50.5? More than 50.5. Means greater than 50.5 liters. They're going to say how many of them was greater than 50.5. Right? Remember now, 50.5 stop up here, sir. So basically the last set, it's more than 50.5. So the last set. You see that? Balance on that? 50.5 stop right here. This is less than 50.5. So 50.5 start here. So the 21 out of 150. But I can say that. These are the ones that are more than 50.5. All right. So that is it. $21 out of 150. That's 7 out of 50, wasn't it? 7 out of 50 the probability. All right. It's a leave answer that fraction. 7 out of 50. Read it again. Petrol to fill the tank is more than 50.5. Yes. 21 of them more than 50.5. All right, next one. The last set is more than 50.5. It's a Byron estimate that the median amount of petrol is this. Estimate of the median. Explain why Byron estimate is incorrect. So to explain why it is incorrect, you will have to determine where the median is supposed to be. And what range the median is supposed to be. So the median is 150 vehicles. The median corresponds to about the 75th vehicle, don't it? Right? In the counting column. Remember that the cumulative frequency column is your counting column. This column is where you're counting how many vehicles you have. Cumulative frequency is your counting column. Cumulative frequency column is your counting. You're counting the vehicles that you have. So you want to know when you reach where the 75th vehicle would be, because the 75th vehicle is in the median position approximately, right? So the 75th vehicle is going to be inside here, so don't it? Position of the 75th vehicle. Position of the 75th vehicle. But I get that. I passed the 59. The 75th vehicle is one of these set. One of these 42 vehicles. But I understand that. So the 75th vehicle fall in this interval between 31 and 40. So the median is supposed to be a value between 31 and 40. Or between 30.5 and 40.5. The median has to be a value inside here. Right? So this will be the position of the median. Position or median value. Position of the median. Position of median. Position of Q2. The Q2 is one of those values. And that's its position. The 75th vehicle is in that group. It's in the third group. So the median is supposed to be between 31 and 40. So if they give a value that is outside of that group, then that's why it is incorrect. No, this 40 point something them estimate. Where is it? This 40.3, 43.5. 43.5 is where? Inside your sum. That's why it's not the median. It can't be the median. Because the median has to be a value in this group. But I understand that. But that's where the 75th vehicle is position. So you have to go and say something about that. You're going to say the 75th vehicle is the portion of median is with the 75th vehicle. The 75th vehicle is in the group, in the class interval 31 to 40. The 40.3, 43.5 that they've stated is outside of that range. That is why the estimate is incorrect. You get me? Something like that I'm going to say. So anyway, you want to write it up, and I would leave those markings on my diagram. These markings to help me explain it. All right? Because only 1 mark. I don't want to write an epistle for 1 mark, but that's what it is. That's something like so something like the median or the position of the median. The position of the median is the 75th vehicle, which is in the 31 to 40 liters interval. This amount, 43.5 liters, is not in this interval. And therefore, cannot be the median amount. That's it. But understand that? You don't have to write those exact words. Write your own words, but that's what it must mean. You're basically saying the 75th vehicle is in the class interval 31 to 40. 43.5 is not in that interval. Now, they could have asked this question another way now. They could give you a value that is correct and explain why it is correct. So, for example, if they gave us 33.5, Because to explain why it is a good estimate. So it'll be the same thing. You said the center of the vehicle is in the 31 to 40 interval. This figure, 33.5, is in that interval, and therefore is a good estimate. Can be correct. Get me? Something like that. So they can ask you, and they can ask you another way. They can ask you to decide whether it is a good estimate or not. So if it is not in the interval where the median is supposed to be, it's not a good estimate. If it is in the interval where the median should be, then yes, it is a good estimate. So whatever way they pose the question, the approach is the same. Why is it the 75th vehicle? Because 75 is half of 150. If it was 200 vehicles, it's the 100 one you don't want. If it was 80 vehicles, it's the 40 one you don't want. And just as though they ask you for the median, they can ask for any other quartiles. They can say somebody said the position of the first quartile is, somebody said the first quartile volume is something. Is it a good estimate? You have to know which cell, which group the first quartile would be. First quartile is 1/4 of 150. 1/4 of 150 is the most. Let me know. 1/4 of 150. You want to do first quartile. We have the first quartile. 1/4 of 150 is wrong. I think this guy becomes 37.5. 37.5. They're like you're looking for the 37 and the 38 student, the average of those two, or the 37th and the 38th vehicle. So you're looking where those two would be, the 37th and the 38th vehicle, which should clearly be inside yourself. 37th and the 38th vehicle would be one of these. Because you're gone past 24 and you reach 59. So you must go past the 37th and the 38th. So the first quarter will have to be one of these figures. You don't have to ask about the median alone, but approach the concept of how you do it. Get me? Find the position where the quartiles will be. Remember, the median is a quartile thing. The second quartile, half of the total distribution. Approximately, that's your position. The upper quartile, 2, 3, is 3/4 of the total distribution. It will be 3/4 of 150 if it was this. All right? So don't know what's coming in the exam. Be prepared for anything. Understand it so you can do it over them ask the question. Let's continue. So that's the explanation right there. See here now. This one says, on the parcel labeled grid below, construct a histogram. You have to remember what a histogram. The bars of the histogram go from boundary value to boundary value. Do not put the bars on the limit values. Very important. And the bars of the histogram, they must join side by side because they represent continuous data. There's no gap. There's no space in between them, between the bars. All right? So they want us to construct a histogram. And this now you need a frequency value for the histogram. Because remember, it's a boundary value to boundary value against the frequency. So you need the frequency values to do the histogram. And that's what I got along by a person. Because person was trying to draw the histogram using these values, not recognizing that those were actually cumulative frequency values and not frequency values. But remember, questions like these that give people problems. All right? Which they should not. All right. So let's put in where the bars are first and then we'll put it in frequencies, right? So the bars, first bar starts from 10.5 and going up by 10 and up to 60.5. That's where the bars are. All right, and they did not scale up the horizontal axis for us down here, so we're going to put it in. So let's say that this is 10, 20, 30, 40, 50, 60. Yes, it can hold. So let's do that. 10, 20, 30, right here, 40, 50, 60. And this down, you're going to put down here the liters, right? Liters. The data is in liters. All right. Let me change this to blue. I'll put the bars in. All right. I'll put the bars in blue. So the bars are going to go on the 0.5 mark, right? So watch this now. This is 10. This is 11, 12, 13, 14, 15. So the 0.5 marks are like right here. So 10.5, 20.5, right in between there. 30.5, 40.5, 50.5, 60.5. That's where the bar is going. Just got about the frequency. The right on the frequency values and copy them there. We can copy them there. Frequency values, remember, are these inside. Those are the frequency values. Put them over here. All right. So the first one, frequency is 24. Let's look at the scale and get it right. The vertical scale is 1. This is 1 to 1, 2, 3, 4, 5 up to 10, right? Let's establish a scale. All right, so the first one goes up to 24. 24 is right here. The first bar is this. This one. Yeah. Use a ruler, please. Don't do it free on the lightning. That's 24. But okay with that? 24. Next one going up to 35. So extend it up to 35. 35 line here, 35. This extend right up to 35 here. Next bar comes up to 35. Bars are on the 0.5 mark. Boundary bar to boundary bar. Next one is at 42. 40 here, so 42 is this line. This is 42. We're coming up to there. Here now. $42. Then we drop down to 28. It's 20 years so we need to be on this line. So dropping onto that line. 28. So this comes up to 28. And I will join in right on 28 line. That's it. The last one drops down to 21. 21 is right here. Coming up here again. Coming across on the 21 line. Join. That's it. Remember, the bars must go from boundary value to boundary value. You can't draw the bar upon the 10, for example, upon the 20. Join them on the 0.5. Lower boundary of 11 is 10.5. So it starts at 10.5. The upper boundary of 60 is 60.5. We put them on all the boundary values. 10.5, 20.5, 30.5, 40.5. That's where your bars go. Don't do that and never lose marks. Come on, let's get this right. Let's get them right. All right, that question done. Next question. Number 6. The scale of a map is 1 to 25,000. That means the 1 centimeter on the map is 125. No, not 125. It's 25. It's 25,000 centimeter on the land. 1 centimeter on the map, 25,000 centimeter on the island. Now the map must be measured in centimeters, right? So determine the actual distance in kilometers represented by 0.5 centimeter on the map. All right? They want it in kilometers. So we have to get the scale in kilometer scale first. And then we'll see what 1 centimeter, half a centimeter is. So let's convert this scale into centimeters first, into kilometers first. So it's 1 centimeter. This is the scale for distance. Distance scale. Distance scale. Distance scale is 1 centimeter on the map to 25,000 centimeters on the land. When convert this time to kilometers, so convert it to meters first, they divide by 100. So it's 1 centimeter to cut off 20 to get it into meters. So it's 250 that meters. To get it in kilometers, they divide by 1,000 now. Divide the meters by 1,000 to get kilometers. So it's 1 centimeter on the map to 0.25 kilometers on the island. 0.25 kilometers on the island. Therefore, it's 1 centimeter on the map. Oh, the one half. The one half a centimeter. The one half this ratio. Multiply by half. Multiply by half. We get the 0.5. So it becomes half a centimeter. You divide this by 2, you get 0.125 kilometers. This is the answer right here. That's the answer. Half a centimeter is 0.25. That was 25, right? 25,000, yes. Then cut off them 20 to get the meters. Then divide by 1,000, 1, 2, 3 to get the kilometers. Then to get a half a centimeter now, you do that. So that is the answer there. But I go to that. Let me shift this down and put map to land. So this is map to land. This is map to land. Or map to actual. Map to actual. Next part. Calculate the actual area now in kilometers represented by 2.25 centimeters squared. So remember, to get the area scale, you're going to square the distance scale. To get the area scale, you can square the distance scale. To get the area scale, square the distance scale. All right? So the distance scale is this right now, right? So distance scale. It's 1 centimeter to 0.25 kilometers. So the area scale is square it. Becomes 1 centimeter squared to 0.25. 0.25. 0.25 squared. 2.25 kilometers squared. Come on, Mr. Shaw. So the 1 squared here becomes 1 centimeter squared, just the same. 2, and then square this. Now 0.25 times 0.25. 0.25, a quarter of a quarter, that's 1 over 8. 1 over 8 is what? So it is 0.0625. That's it. Kilometers squared. But I want it for 2.25. So to get for 2.25, let's multiply this by 2.25. Simple as that. Let's multiply this now by 2.25 to get what they want. So we take this now and multiply it by 2.25. So talk to me now. Multiply this by 2.25, we get it 2.25 centimeters squared. 2. Multiply this now by 2.25. Tell me what you get. 140,625 kilometers square, and this is the answer. That's 2.25. Actual area in kilometers squared, that's it. 0.1. So that's what when you multiply this value by 2.25, right? That's what you got, right? All right. That's that. Next question. Well, a different question. It says, the diagram below, one I never like this paper, that numbers. The diagram below not drawn to scale shows the cross section of two cylindrical jars, X and Y. So this is the X1 and that's the Y1, right? Both of them cylindrical. It says the diameter of jar X and jar Y are 3D and D, respectively. 3D and D, those are the diameters. So the diameter of this is 3D, then the radius is 3D over 2, and the radius of this one, let's put a big R for the big radius, big R. The small one, just D over 2, right? Small radius on this one, small R, D over 2. All right, X and Y. All right. The question says, initially jar X is empty, this one is empty, and jar Y contains water 4 meters, to a depth of 4, not meters, centimeters. It says, determine in terms of pi and X, meaning pi and D, sorry. Pi and D must be in the answer. The volume of water in jar X. The volume is going to be, volume in jar X is going to be pi R squared times the height of water, don't it? Let's call it HX. This is HX, a height in X. Good? This becomes pi times the radius is this. 3D over 2. So it's 3D over 2 squared times this 4 times 4 for the height. That's what we're working. Leave an answer with the pi and the d in it. So watch this now. This 2 squared, cancel this 4. And I'm going to end up with this 3 squared, which is 9. So it becomes 9 pi d centimeters squared. Centimeters, yes, centimeters. But understand that 9 pi d centimeters is the volume in jar X. But go to that 9 pi d centimeters cubed, not squared, Mr. Shaw, cubed is volume. Next one says, if all the water in jar X is now poured into jar Y, calculate the height reached in jar Y. In jar Y, because it's thinner, of a smaller radius, it's going to come all the way up here, don't it? Let's call that HX, the height in HX that the water is going to do. So the volume is going to be the same, that's all. The volume is going to be the same, just that we don't know what the height is going to be. You see it here now? The volume in jar Y is going to be equal to what the volume was in jar X, don't it? Now in jar Y, the volume in jar Y is going to be pi times the small radius times the height of Y. Pi R squared, pi squared, pi R squared. Pi R squared. That's the volume in jar Y. It's going to be equal to what the volume was in jar X, which you know it already. It's this. 9 pi D. 9 pi D. That's what we're working on. So the pi is going to cancel. You can see that already, you know. These pi's cancel on both sides. All right, the pi's cancel. Then this R, this is R and X, right? The small r. And the R and the small one was D over 2, don't it? And squaring it. So this becomes D squared, D over 2 squared times the height on Y equals 9D. Hold on, man. I make a mistake, you know. This is supposed to be a D squared. No, look, you know, nah, look, you know, it's supposed to be a D squared. Squared. Yes. So it's supposed to be a D squared. Squared. What is that? So this one becomes D squared over 4 times HY equals 9D squared. So the D squared them cancel again. So D squared and D squared are cancel, right? And so you just take this 4 and multiply it over here so to get the H. So the height in Y becomes 4 times 9. So the height in Y is 36 centimeters. That's it. I think I do a little bit too much work, but that's it. So just the volume in the small one equal the volume in the large. We can't put the right one. Next one. Yeah, this question is one that people complain about. But they didn't give the regular pattern with diagrams and stuff for this one. But they give a pattern, a mathematical pattern. The entropy of a sequence like this. You know that first term in the sequence is 1. So the first term said that Tn is when n equals 1, you put 1 here. So the first term is T1 is equal to 3 times 1 squared minus 2. That equals 1. So the first term is 1. Answer. Get that? That is it. N equals 1. We say, what is the third term? That's T3. So T3 you want. So it means you put in 3 in this formula. So it becomes 3 times 3 squared minus 2. Now this is just 27. 27 minus 2 is 25. So the third term is 25. That's it. It says, given that Tn equals 145, what's the value of T? I have to put the formula for Tn equals 145 and solve it. So to remember now, is 3 times n squared minus 2 equal 145. That's what to solve it. 3 times n squared minus 2 equals 145. That's what you're solving. Take this minus 1, bring it over here, add it. We're going to get 3n squared equals 147. They will divide by 3. 147 divided by 3 is how much? N squared equals how much? 49, don't it? That's right. This is divided by 3 is 49. Looks so, don't it? Yeah, because 3 times 40 is 120, and 3 times 9 is 27. Good. And then now you're going to square root that. And so the n equals the square root of 49, which means that the n is equal to 7. So that is the answer, 7. But I got it that? Not easy. Not hard. That was a pattern question. This is what gives people problems. Our teachers complain about. This is the first 8 terms in a sequence. This is the sequence of a particular name, and I don't remember the name of it, right? The particular kind of sequence. The first 8 terms in another sequence is given as this. The n term un is given as that. So this is u1, this is u2, this is u3, this is u4. So they give us some other values here. u1 is 1, that corresponds to this. u2 is also 1, corresponding to that. Then the formula for un is un minus 1 plus un minus 2. What does that mean? It means that a value is equal to the sum of the previous 2 values. But this is the first value before. This is two values earlier. I'll give you some examples. So u5 is the sum of u4 and u3. What that means? That means that this value is the sum of these 2. This 8 is the sum of these 2. This 13 is the sum of these 2. This 21 is the sum of these 2. So a value is the sum of the 2 preceding values. That's what's happening here. That's why this 2 is sum of these 2 values. All right? That's what they want. All this information is about picking up that pattern. It says write down the next two terms in the sequence. That is U9 and U10. We can write them down here. So the next term, you have to add these two, don't it? Which is what? 34. And the 34, let's write it up here. So this 34 is 13 plus 21. Then the next term is the sum of these two now, don't it? That's 55, don't so? And that 55 is now the sum of these two. The 21, the 13 plus 21. So 21 plus 34. 21 plus the 34 gives us that value. So those are the next two terms, right? This was 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But I want us to write, yes, the 9 and the 10 term. That is it, the 9th and the 10th term. Let's write them out for the examiner here. So I'm going to write that U9 is equal to 34 and U10 is equal to 55. Nice and easy. Next part says, what term in the sequence is U18 and U19? Must U20, don't it? Remember, a term is the sum of the two preceding terms now. What term in the sequence is the sum of U18 and U19? The 20th term. Remember, I have to put the value, you know. So what term? The 20th term. I don't have to tell them what the value is. The 20th term. So U18 plus U19 is equal U19 is equal to U20, i.e. 20th term. The 20th term. The question never asked for the value of it. Just asked for what term? The 20th term. Which term? The 20th term is U18 plus U19 because it has to be two terms before U20. 20th term. See, 1 mark. So couldn't be asking for the value. Next one now says, show that U20 minus U19 is equal to that. So I want to start with this side and break it up to get this side. So the left side is, these two is U19 plus U18, note it. U18 plus U19, note it. These two. So this is U18 plus U19. That's these two. Minus U19 now is U17 plus U18, note it. If U19 is actually U17 plus U18, some of the preceding terms, right? But I go to that. This inside there says U20 and this inside there says U19. Let me write it up here. So this is U20 and this is U19. They're going to open up and subtract now. So U18 minus U18, the U18 gone. Everybody can see that? So them two U18 are gone. And so you are left with this U19 minus this U17. So you end up with U19 minus U17, which is the right side. It's equal to the right-hand side. Therefore, sure. But I go to that. That is it. All right. Next question. Question done. Section 2 now. 3 more questions are done. This question said to give us these two functions and state the value of x that cannot be in the domain of f. You see that? That's asking for the undefined what value make the function undefined another way. The value of x that cannot be in the function in the domain of f is what will make the denominator equal 0. You get me? Good. So that is when 2x plus 1 equals 0. This means that f is undefined. That means that f is undefined. Same thing. The same question. That's when x equal minus a half. Q over the 1 and come minus 1 and then divide under 2. So x equal minus half cannot be in the domain. X cannot be minus a half. Minus a half cannot work on this function f. It's going to cause it to be undefined. Going to make the denominator 0. That's it. Finding simplest form, f of g. Remember, f of g means g into f. G into f. So you're taking this g and bringing it into f right there. But I can say that where the x is. All right, so let's just write it. Becomes equal to 9 over 2 times, that's x minus 3 where the x was, and then plus back a 1. And we have to simplify it. This becomes 9 over, this product becomes 2x minus 6 plus 1. So it becomes 9 over 2x minus 5. That is it. But I go to that. That's how I put g into f, right? All of g into f. What else I want us to do? F to the minus 1. So doing the inverse of this function f. 9 over 2x plus 1. So we're going to start by saying f equals 9 over 2x plus 1. We're going to inverse it. This f becomes x equals 9 over 2 times. This x becomes f to the minus 1 plus 1. And you're trying to make this a subject now. Easy. I'm going to take all of this, multiply it over here, take this x and divide it. That's not the only way to do it. If we multiply by the x and expand it out, just the same. But let's do it that way. Take this, multiply it over here by the x. So it becomes x times this first, which is 2x f to the minus 1. And then x times this one becomes plus x. And that's all equal to 9. I want to leave this as a subject, guys. You must see it. I can carry this over and subtract it and then take this 2x and divide it. Tell me if you don't see this. F to the minus 1 becomes equal to 9 minus x all over 2x. But can I say that? Take this x, carry it over here, so become minus x first. And then take this 2x and divide it under here. That is it. Now that we're done, we can put in back the of x. That is it. 9 minus x over 2x. That's not the only way to express it, but it could have been 9 over 2x minus this divided by this, half. So I made that as well. All right? But anyway, that is it. 2 marks for that. Next part. Okay, this now. This question said diagram below shows 2 rectangles, A, B, C, D, and G, F, E, D. That's inside here is this one. And this one is A, B, C, D. That's this one. It says A, B, C, D has an area of 44. All right, so the big one has an area of 44. All right, it means that this length times this length is 44. That's what it means. All right. It says bang, bang, bang. G, D, E, F has sides 4 centimeters. That's here is 4 centimeters. And 2 centimeters. That's here is 2 centimeters. So that's a 4 by 2. All right, that's a 4 by 2. And then AG equals EC equals 3x. So this is 3x, and that is 3x. All right, so everything that they have said is on the diagram. All right, it says by writing an expression for the area of the big rectangle, show this equation. So we know that this side times this side equals the 44. That's what we know for the area, right? So this side is 3x plus 4. 3x plus 4 this side. So 3x plus 4 times this side is 3x plus 2. That's all equal to the area up here, so which is 44. What good at that? It's a matter of transposing this and simplifying now. I want to put this over there. Let's expand this first and then transpose this forward. Right? The 3x times 3x is 9x squared. The middle term is the far product and the near product. One of them one by one. 3x times this 2 is 6x. Then 4 times 3x is 12x. Then 4 times 2 is 8. That's all equal to 44. All right, consolidate and simplify down to this. 9x squared. That's this one. This is 18. 6 and 12 is 18x. Minus. Can I take this and subtract it over here? So 8 minus 44. 8 minus 44 is how much? 8 minus 44 is how much? 36 equals 0. Then now we can divide everything is up by 9. These are all multiples of 9. Divide through by 9. Divide this by 9. Becomes x squared. Divide by 9. Becomes 2x. Divided by 9 is minus 4 equals 0. Shown, same thing. Therefore, shown. That's shown. All right. We need to solve it. It says, calculate x to 3 decimal places, the value of x. So you know we're going to use the quadratic formula. Once I say that, the 3 decimal place, you know, we're going to use the quadratic formula or complete in the square or something. Means that you're not going to do by a factor. Calculate the value of x. So what do we have again? We have x squared. What is can factorize? Can factorize. Factors of 4. Like 1 and 4 are 2 and 2. And all the factors are 4. They can't factorize. That is the quadratic formula. So we're going to get x equal minus b. The b is 2. Minus 2. Plus or minus the square root of b squared. The b squared is 2 again. That's 2 squared. Minus 4ac. 4 times 1 times c is negative 4 right here. All over 2a. 2 times 1. Now look here. This minus is going to give a negative answer. And the length can negative. You're going to use the positive. You understand that? A length can negative. Length of something can negative. The negative 2 here, if you use the negative on this, whatever that work out to, you end up with a negative value. So the only answer is only on the positive right now. The answer is only on the positive right now. The positive alone is what giving you an answer. The answer is on the positive. We're going to work that out to the positive and just work it out here. But we cannot accept the negative. The negative is not valid. So that is it. So let's work it out with the calculator. If you work out the two of them, you have to ignore the negative anyway. But I know that I don't need to work out the negative. The length of something can negative. So it becomes a fraction minus 2 plus square root of 2 squared. Now what is now? It's minus 4 times minus 4 going to give me a positive 16 plus 16 all over is 2 times 2. Is 2 times 1 is 2. That's 1.23. 1.23. That's the 3 decimal places. So 1.236. 1.236. The 2 decimal place. That's what x is. And x is just a value, because the question did say x centimeter. Did it say x centimeter? Yes. 3x centimeters, for example. So x is just a value. But x is 1.236. It says calculate the perimeter of the unshaded region. Careful now. The unshaded region. I want the perimeter of the unshaded region. So the unshaded region is right here. This piece, this piece, this piece, this piece, this piece, this piece. That's the unshaded region. Let's put on the dimension on it. Right here says 4. Right here says 3x. Right over here so is 3x plus 4. And up here so is 3x plus 2. And right here so is 3x. So adding up all those sides to get the perimeter unshaded. The distance around the unshaded region is the perimeter. It works out that in the computer. All right. So the perimeter unshaded equal. Let's start with this side over here. Is 3x plus 4. Then up here, sir. This is over. Okay, adding up everything. Plus 3x plus 2 plus this 3x. Plus 3x plus here, sir. Plus 4 plus here, sir. Plus 3x. And adding up all of them. See that? So it's 4 3x right there, that's 12x. And then this works out to 10. 12x plus 10. So it's 3x, 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 and 3x. That's 12x. And then it's 4 plus 4 plus 2. That's it. What is it? 12x plus 10. I will put in the value that we know for x, right? The perimeter shade all. Let me copy this down and put it down on the page. Copy. Perimeter shade is that becomes equal to 12 times 1.236 plus 10. I wrote that out to the calculator and put down sign centimeter. That work out to. So everything comes to 20, yeah, 24. 24.832. Get them about the 3 decimal place again. That's it. Centimeter. All right. Next question. Number 9. 2 to go. So the diagram below shows a circle where AC is a diameter. Remember, angle subtended by a diameter is 90 degrees. So right away, this angle is 90 degrees. Always at 90 degrees. So angle subtended by a diameter is 90 degrees. All right. It says D and D are 2 points on the circle, and DC is a straight line. So this is not a tangent. That's not a tangent. You cannot be using any tangent and anything rule. No tangent rule. That's not a tangent. This angle up here says 28 degrees. And this angle inside it says 46. So everything is given there. It says calculate the value of each of the following angles. Show detailed work where necessary. Give a reason to support your answer. First angle they want is angle DBA. Where is that? DBA. DBA. That's this angle they want up here. So they want this angle. That angle is just part of this 90, you know. That angle is just part of that 90. You can see that? They want this angle. But the total angle across here says 90. That is subtended by this diameter. So therefore, that piece that they want is 90 minus 46. And I tell him first that the angle ABC is 90. Let's tell him that first. And him say, sure working. Angle ABC equal 90 degrees. But angle subtended by a diameter is 90 degrees, right? When I say subtended by a diameter. Subtended by diameter. Which diameter we're talking about? AC. That's why it is 90, right? So we're saying all of this is 90. Therefore, angle DBA has to be 90 degrees minus a 46 degrees. What is that? 44 degrees. Beautiful. That's the answer right there. Let's put it on the diagram as a find. This angle is 44 degrees inside here. 44. What else I want? 44 degrees. So this is my reason is up there. The one angle now DAC next. DAC. Where is that now? DAC. You know what now? This angle. Now let's see. That angle is 46 enough. I want to know. Because if I find the chord that is subtending it by coming back till I reach the circumference, coming back, that's the circumference. I come back along this side, I reach the circumference. That means that that angle is being subtended by this chord, this purple chord. That same purple chord is subtending this angle up here that I'm marking out in green. It's 46. And those two angles that we want are equal. They are in the same quadrant, same segment across from this chord. But they are equal. Same segment rule. That angle up this is 46. That one. 46. Let's put that. This angle up here is 46 degrees. Same as this one. Because they are both subtended by this chord. If you like, both subtended by that eye. So 46 degrees, same segment rule. This angle down here is 46 degrees. With that angles in the same segment. Are equal. Then they are subtended by the same chord or by the same margin. 46 degrees. What is the one? Angle BCE. Where is that now? Angle BCE. So I want this angle out here, so now BCE. Remember, that's not a tangent, right? That's angle BCE. This angle out here, I want this one. All right, we can find that one. So that angle is exterior to this triangle right now. Remember, that's not a tangent. So don't go talk about no tangent and chord. Not a tangent. But it's exterior to this triangle right now, right? So if I can find this angle, if I can find this angle, add it to this angle, then this angle out here will be equal to the sum of these two, this and this. Sum of those two. But then this angle is equal to 28 degrees. Because they are both subtended by this chord. So those two angles equal 28 degrees. But the angle out here becomes 46 plus 28. That's what it becomes. External angle equals sum of the two interior angles. Exterior equals sum of two interior. So I want to tell him first, tell the examiner first, that this angle is 28 degrees, right here. Maybe there are other ways to do it, but that's what I'm seeing right now. That angle is 28 degrees. Out of the same segment here. So tell him that first. This angle is 28 degrees. Same segment. Angles in the same segment are equal. Double talking. The angles in the same segment are equal. That's why this is 28. I'm going to tell them now that this angle out here that I want, this angle out here that I want, is sum of these two. This angle out here now is 28 degrees plus 46 degrees. What is that up to? What is that? I know could I say again, it is the exterior angle of this cyclic quadrilateral. That's another way we could say it. And this exterior angle equal the sum of the two opposite, equal to the opposite interior angle of a cyclic quadrilateral. It's still equal to 48 plus 20, 46 plus 28, just the same. So we could have used that as well. But let me just use the exterior angle of the triangle still. All right, so let's work out now. This process is how much? 28 and 40. How much? 74. And that's because the exterior angle of the triangle is the sum of the opposite two interior angles. I could say it equal to 1 over there. Whichever way. Maybe they want us to use the cyclic quadrilateral because these were already there. Let me use that here, man. Forget about this. We're not going to use this. Let's use the exterior angle of the cyclic quadrilateral for the opposite interior angle. So that blue angle that we want equal this blue angle across here, which is the 28 and 46 MV. So the exterior angle of a cyclic quadrilateral equal the sum of the two opposite interior angles. That's what this is. Let's go and write that. 46 plus 28, 24. Exterior angle of a cyclic quad equals the opposite interior angle. Interior angle of a cyclic quadrilateral equals opposite interior opposite. The opposite interior angle. That's it. Yes, no, that no. This one now gives us a diagram. We're going to be using on this. It says, diagram below shows the quadrilateral PQRS where PQ and S are parallel. This is an indicator that they are parallel. I'm going to put them PQ and S are parallel. Put on these arrows to remind me that they are parallel. Once you have parallel lines, you have your Z angles, your U angles. For example, you have a Z inside here. Automatically, this angle is 30. Right? Then now, with 90, so this is 92. Right? It says 60. I just have 60. Those are some of the things we're looking for. Additionally, this angle, those two add up to 180. Like that, the angle inside the view down here, so with those parallel lines. Co-interior angles. Right, so identify those two. But anyway, let's continue. So this length is 8 across here. This angle is 90 degrees in here. This angle is 2 degrees in there. This angle is 30 degrees down here. Let's say find the length of PS on this side. So to find that side, we're going to recognize that this angle up here says 30 degrees. I don't put no rule. This is not write the rule. Put on the diagram. This angle is 30 degrees. We'll add it on the diagram. 30 degrees Right here, 60 degrees. We're working at it with the 30 with the 60. And let me leave the 30. And so we're working with the 30. Right? And we're trying to find this side, which is the opposite, and that's hypotenuse in that triangle, right? You want to say in triangle ESQ. ESQ. We're going to use sine equal opposite over hypotenuse. Sine of 30 degrees equal the opposite PS over the hypotenuse of 8. It's a PS of 4, but the sine of 30 is a half. So the PS equals 8 times the sine of 30 degrees. So the PS equals 4 centimeters. Because I know that the sine of 30 is a half. Put on the diagram as you find. But this side is 4. Put on the diagram as you find. 4 centimeters. That's right. Next part says we have to calculate the length of PQ. PQ is that PQ. That's this side over here. Pythagoras' theorem now can give us that, right? Or if you want to use half equal adjacent over hypotenuse. Either way, you can use these two sides. These two sides, sorry. Pythagoras' theorem to get this one. Let's just do that. Pythagoras' theorem. We get this side. PQ. Square root of 8 squared minus 4 squared of PQ. Using Pythagoras' theorem. So PQ equals the square root of 8 squared, the hypotenuse squared, minus the other side squared. That's 64 minus 16, don't it? 64 minus 16 is the what? Square root of what? 64 minus 16 is the what? Pick. 48. The square root of 48 centimeters. You want to simplify it further, fine. I got a 48 centimeters. Next part, we want the area of PQRS. Let's look at it. PQRS. PQRS. So the one here of everything. The one here of everything. PQRS. All right. So the part it's a trapezoid, right? It's like one pair of parallel sides, right? So to be half the sum of the parallel sides, that's this and this, and the distance between them. That's one way. What we can do, to find the area, PQRS. We're going to need the area of this triangle. We can find the area of this triangle plus the area of this triangle. So how do we get the area of this triangle? We need at least one side. Watch this now. Let's populate it. We have this angle, we have this angle. We can find this angle. All right. You find this side will go. Here is trapezium. Here of a trapezium, right? We find this side will help us. But here the whole thing will be half the sum of these two parallel sides times this distance between them. You know this side up here already. We just worked it out a while ago. And so we need to find this side now. This is the distance between them. Perpendicular distance between them. But this is 90 and this is 90. We need this side. To find this side, we're going to use sine rule in this triangle to find this side. So we need this angle down here. We work this angle along with this side in the sine rule, and then this two in the sine rule. So we need this angle, which is easy right now. This angle down here is 180 minus sum of these two. Work it out for me. This angle is 180 degrees. 180 degrees minus sum of those two. Minus 82 and 12. What is so confused? Let's work out it. How much? 58. We need to find that side. SR using sine rule. Right? Use sine rule to find SR in this triangle. So use these two, these two. Let's just use kind of speed since you have other numbers. Let's use your output. When you use sine rule, for SR. You understand? SR over sine of an angle opposite to SR, which is 82. Equals the side that we know, which is 8 over sine of an angle opposite, which is 68. And so the SR comes 8 times sine of 82 degrees. So take this 82, sine 82, and multiply it up here, over the sine of 68 degrees. Remember where this all coming? SR equals what? 8.5? 8.5. What is it? Centimeters? Centimeters. So that's 8.54. Put down in red, Mr. Shaw. 8.54. 8.54. What was this up here again? What we did? Let's write this out, the root 48, and come on again. Where is it for me? Not decimal. Give me 3 significant places. Root 48 is how much? Well, give me 3 digits. 6.93 centimeters. So those are the figures we use here. All right. And we just worked out that SR is, what is it? SR is 8.54. 8.54 centimeters. And then the distance between them is 4 centimeters, right? Distance between them is 4 centimeters. That's the PS. PS is 4 centimeters, right? So the area then becomes half the sum of the parallel sides. These are the parallel sides. That's the 6.9, the 8.54, and the distance between the parallel sides, the perpendicular distance between the parallel sides, which is 4. That's what you're working with. That's what I give you now. 30.94 centimeters square. Somebody got it right. Aha. Next question, please. The last one says, find this matrix product. Must have the 8 and the 10, right? So working out this matrix product is going to be equal to 2 values, one up here, one down here. Remember, you multiply the rows of the first matrix with the 1 column. Let's zoom up and do it. So this first value is in the first row, first column. So to get it to multiply this first row by this first column. First element times first element, second element times second element. First element times first element, second element times second element. Minus 1 times k, and 3 times 5. Minus 1 times k is minus k, and 3 times 5 is 15. So that's plus 15. Then the second value down here is positioned in the second row with 1 column. So multiply and this second row with this 1 column. Second element times second element. First element times first element. Second element times second element. 4 times k, 8 times 5. 4 times k is 4k. And 8 times 5 is 5 each. That is the answer right here. That is it. You can simplify this. All right, this has 50 minus k. And then this now is still 4k plus 5. That is it. All right, it says, hence, find value of h and k to satisfy the matrix equation that is equal to 0. Means that this matrix that we just calculated no equal to 0. So what is saying is that 50 minus k and 4k plus 5h must be equal to 0, 0. It means that each of the values is 0. So this equals 0. So for this to be equal to 0, the k has to be 50, noted. But can I say that? And then for this to be equal to 0, we're going to say and this part equals 0. But the k is 15, so you can put the 15 there. So for the k, it's going to be 4 times 15 plus 5h now equals 0. All right? Now this is what? Divide through by this 5, we get 4 times 3 plus h equals 0. So the h equals negative 12. So k equals 15, h equals negative 12. But can I say that? Oh, that is it. All right. Use a matrix method to solve the simultaneous equations. We're going to write this as a matrix equation first. X value, y value good. X value, y value good. It becomes a 2 by 2 times the column xy equals this column 5, 13. And the coefficients of this going in here now. So it's 2, 3, negative 5, 1. There's no one that the coefficient is 1. Negative 5, 1. So forget the xy, the inverse of this going in front here, right? So the xy is going to be that the inverse of, what is this? 1. 2, 3, minus 5, 1. I put the negative one in red so you don't miss it. That's the inverse of this matrix coming here. In front of the 5, 13. That's going to give you xy. So we need to work out what the inverse of that is first. It's 1 over the determinant times the adjoint. So it becomes 1 over the determinant. What's the determinant? This product here first is 2 times 1 minus this product, which is negative 15. So you're subtracting a negative 15. Multiply by the adjoint of this now. Interchange the elements on the first diagonal. So you have 1 up here, 2 down here. Leave these 2 on the second diagonal where they are, but you change the sign. This should become negative 3. This negative 5 becomes 5. So this right now is just the inverse matrix. All of this is the inverse matrix calculation right here. And multiply that back by this 550, 530. And generally, you multiply these two and leave the fraction out here for last. When this becomes a plus, it's minus a plus, that becomes 1 over 17. So this then becomes equal to 1 over 17. And I want to multiply these two matrices now to get a column matrix like that. Same process again. The rows times the column. So the first value here is this row times this column. First element times first element. Second element times second element. So it is 1 times 5, which is 5. And minus 3 times 13, that's negative 39. Then this value here now is this row times this column. First element times first element. Second element times second element. First element times first element. Second element times second element. 5 times 5 is 25. And 2 times 13 is 26. So this reduces to some nice numbers. 1 over 17 into, this becomes negative 34, which is 2 times 17. That becomes 51, which is 3 times 17. So we divide each of these now by the 17. This one is negative 2. And this one, we divide by 17, you get 3. So it is the xy not as equal to those values. State the values of x and y explicitly. Don't leave this as the answer. So you have to write now that the x equal negative 2, x equal negative 2, the y equals 13. Y, not 33, y equals 3. And these are your answers right here. But okay with that? But good? Next question. vectors. And then we're going to be done. Done. Yeah, clap. You're going to buy food. Eh? Food is that, you know. When I turn maths, someone turn for the next 2 weeks. When I turn maths for the next 2 weeks. Let's go. When it is one origin, all the portion vector of A and B are 9, 0, and 3, 6. Easy, you know. It says that 9 units out here, so. And this one at 3 this way, 6 up, so. That's what that means, you know. Like on a graph. Just like they don't put on a graph. It's not complicated. Point D and E are on AB and OA respectively, and are such that AD is 1/3 of AB. AD is 1/3 of AB. So AD is 1/3 of AB. All right. So it's a 1/3. So this is a 2/3. But understand of AD, right? Good. So like 1 to 2. And then now, same thing down here, so. OE is 1/3 of OA. So again, it's a 1/3 of the whole thing, and it's a 2/3 of the whole thing, right? All right, so 1/3 and 2/3. Question said, express the following in terms of the vector form AB. Which vector do you want? The one the vector AB first. This one easy because we know the OA and we know the OB, right? So we can use O times the last minus O times the first. OB minus OB. The OB is this one, 3, 6. Minus the OA, which is 9, 0. That becomes equal to negative 6, 6. See? AB, to go from this to this, you have to come back 6 away there, and then go up 6 away. That's what it means. You have to come back 6, that's negative 6, and then you have to go up 6. Makes sense. All right, to go from A to B. Then it says, must get the vector OD now, OD. We'll go from O to D. Easy. To go from O to D, we're going to say, we'll go from O to A first, and then go from A to D, where the AD is 1/3 of the AB that we just found. Everybody see that? Good. So we're going to OA plus AD. Let's write it out. So go from O to D, you're going to go to O to A first, and then go from A to D. That is OA, and then the AD is just 1/3 of the AB. And the AB is this, minus 6, 6. So the OA is 9, 0, plus 1/3 of the minus 6, 6. Which become, now, this divided by the 3 is negative 2. So that 9 minus 2 is 7, don't it? And then this divided by this 3 is 2 again, and it's 0 plus 2 is 2. 7, 2. Let's see if it makes sense. So from O to D, we're going 7, 2. Let's see if it makes sense. 7, 2. 7, 2. You say go 7 this way, and then go 2 up. Makes sense. Go like 2 up, like that for 2. 7, 2. So I can accept that answer. I can accept that answer. Nice and easy. Next one I want is what? BE. BE. Let's look at it now. We'll go from B to E. B to E. All right. When I come down to O first, I could use O. We can use one BE. We can use OE minus OB, you know. But we know that the OE is 1/3 of the OA. This is 1/3 of the OA minus OB. But that's that. The OE is 1/3 of the OA. So we can use a method here now. Let's copy this down. Exposure vectors on this one. We have to figure it out. Just use O times the last minus O times the first. And we read it. So the BE, we're going to say it is OE minus OB. O time the last minus O time the first. And the OE is 1/3 of the OE. That's what the question said. Minus the OB. Ready to put in the values now. Remember the OA is 90 now. This is 1/3 of 90 minus OB was what again? 36. 36, yes, 36. That answer is -6, you know, which kind of makes sense, you know. Go from B to E, it just come down 6 like that. Bang. 6 down, that's -6. Answer is just 0, -6. Makes sense. Diagram calculation match it. Because this now is 1/3 of 9 is 3. 3 minus 3 is 0. So it becomes 0. And then now 1/3 of 0 is 0. 0 minus 6 is -6. So I can accept that answer. So from B to E, there's also 6 down like that. 6 down. B to E. Bang. 6 units down. End of this test. And that is that. Right. Nice. All right, guys. So you know it is. You know it is. So do the thing for me now. Any question I get wrong, we're going to work it over. Any question I never do, you're going to do it. All right? Any question I get wrong, you do it over. Any question I didn't do, you go and do it. Remember, guys, I sent 2 papers in the group. I send them today again. 2022 papers. Both of them must come by Wednesday. And look out for me to send a message in the group if I'm going to have an all-day Wednesday and an all-day Thursday. I think I want to have an all-day Wednesday and an all-day Thursday. So come out, practice some work throughout the day, Wednesday and Thursday, and I will still have a class in the evening. I tell you exactly how it will go.
Sir.
Stop it. I think we'll do that after the first exam. We'll have a class where we go through all the past papers and man say. Test not on paper 2.
Sir.
That's only coming out the multiple choice. Yes. There's something that I might need to review, guys, before though. I might need to do some probability here because I find that the probability that they're setting in recent times. Talking about or that's after and you want to the probability or you add the probability and they're giving some sample space and so on. So you need to understand a little bit more for probability. After I think I'm going to have a class, we will do some probability that might be some systems right? What I see the set the last 2 exams. All right, so that's something that we need to do before that exam. Yes, somebody online asking a question.
Sir, I was saying I was going to be late for the Thursday one because I'm going to have orals that day.
Oh, you have orals, you have an exam, you have French oral.
Yes, sir.
Oh, what time? At 9 a.m. I
Yeah,
decide.
the start time is now.
The first thing you have to do is make sure that the room is available. That they're not using it during the day. Otherwise, we'll just have our normal thing. But more than likely, Saturday coming, more than likely it's gonna be all day again. Saturday for sure. Because we have to put in some time. All right. But do not let it be that when you come back to class on Wednesday and Thursday, you have not completed those 2 papers that I've sent you. Please. Very important that you do those 2 papers for me, please. Do those 2 papers so we can have a nice, easy, fun time Wednesday and Thursday, please. All right? That is it. Bye, everybody. The 2022 papers that are sent in the group, do them before Wednesday and Thursday. Both of them. Both of them. Admas people, let me hear from you now. Remember, Admas due 3 o'clock today. What time is it now? 2 o'clock. Admas due. I'm going to end the class now. Bye, everybody.
Bye, sir.
Bye-bye.